Okay. All right. Hi, everyone. You have made it to the Hyak workshop called Containers Are Your Friend, which is super exciting and kind of a full circle moment for me. I'll get into more about that. But first off, I'm Kristen Finch. I'm a staff scientist with the Hyak team, and I play the role of facilitator. So I work the help desk and I answer a lot of questions about how do I do this or that on Hyak. And what that usually entails is that you have a software that you want to use and you can't install it because you don't have root or administrative privileges to sudo install something. And we're going to talk about why that is. And that's a lot of what I cover as your ticket expert whenever you write into help@uw.edu with Hyak in the subject line. That's how you can get in touch with our team. Let us know if something is not behaving as you expect it to on Hyak, or if you have those general help questions about how do I do this or that. I'm totally happy to help answer that. And I usually, if there's anything that I can't answer, pass it on to the system administrators that keep Hyak going. So I used to be a postdoc in biology before I started this job in March 1st this year. And so I have about 2.5 years of being a user on the user side as well. And the reason that I say that containers and I have come full circle is because it's kind of comical that I've named this workshop Containers Are Your Friend, because I had a love-hate relationship with them when I first got to University of Washington as a postdoc, and I found out that this was a necessary thing that I had to learn. But now that I have learned this, I see the full benefits of containers, and that's something that I'll be sharing with you today. I'm working on a training schedule to continue into the fall. And so Kyla, if you could drop the post-workshop survey into the chat, then I would love to have your feedback on this session, and it'll help me to tailor these sessions to be more beneficial in the future. If you liked something, didn't like it, lock it away for now, answer it on the survey, and that is much appreciated. All right, so our learning objectives for today are to understand Hyak software policies, to become familiar with containers, to become familiar with the benefits of containers for your reproducible science, and that's kind of the star of what I'm talking about here with containers can be your friend because they can give you these benefits that you might not realize right now once you become an expert at them. You can understand your container usage from this workshop, that's a big one, and then also have some practice building containers on Hyak. And then other container resources that are out there for you because you don't have to do everything yourself. Okay, and if we get time, I'm going to show you how to also send a command to a container with Slurm, but that was kind of a discussion of our last session, so only if we have time, I'm going to go through that. So to get it kicked off, Hyak software policies. So Hyak is a shared resource environment or research environment, and we have a baseline environment that fits the most users. And so really we like to keep it minimal. They're loaded onto all of the machines in the cluster have the same operating system and environment, and we kind of try to keep this uniform and not bog it down to cause any other headaches that there might be. And we do not allow anyone to have root or sudo access or be an administrator on Hyak machines. So if you run into a software that needs that, a container is a good way to get around that, installing a module, or writing us a help ticket and we can help walk you through that. But the reason is that we don't want to have a user install some software, change something about the shared user environment, and then disrupt the research of other users in the community. So it's very important that we keep that. And even though that's the case, it's still the responsibility of the researchers, right, of all of you, to have the software that you need, make sure that it works, have all of your versions tracked so that you know exactly what software you're using. Because ultimately, if you're publishing the paper, if you're publishing the study and you're using the University of Washington resources, you're the one that's on call for, is this research reproducible? And so we put a lot of the responsibility onto you to install those softwares, but it's our responsibility or our duty to help you do that in the ways that fit with the software policies for University of Washington and the Hyak system. So we have documentation, which is here on the browser side of my screen. This is on our documentation website, which is hyak.uw.edu, underneath the tools and software side of the menu, and then Apptainer, formerly called Singularity, we'll be talking a lot about today, and Docker. And so this is a little bit of what we're going to talk about today. We're going to go more into depth. And then if you look here, we also have GPUs and NVIDIA NGC containers. This page, this was contributed by a facilitator at NVIDIA that talks about how to use containers that were built by NVIDIA to really get the most out of your GPU experience. All of our GPUs are NVIDIA on Hyak, so this can be a really good resource for you. And we're going to talk about both Singularity Apptainer containers and then also containers built by NVIDIA today. All right, and I should say that the Apptainer user guide is really going to be your go-to for any in-depth kind of installations. We're going to talk about really just scratching the surface of this. This is a great resource to go into depth, and this workshop should really not replace the documentation that is available here for you from Apptainer Online. And I really should say that a lot of the softwares, and we're going to get more into this, a lot of the software that you want to use for your research is probably out there as a container, because software developers have found out that you can really put out a lot of fires or kind of shut down some of the tickets or issues that might come in by providing these containers, which I haven't told you what a container is, but you'll see that it really is a great way to package your software, all of the dependencies, make it portable and shareable. And so developers are really behind this. All right. So next, I want us to go ahead and get logged in to Hyak, because I know that we all have to, for this workshop, we're going to need to request a compute node, all of us. And I want to just make sure that we all have time to get that compute node allocated to us so that we can move on and everyone can be following along in real time with the demonstration. So what I want you to do is open up a terminal. I'm using the terminal from Mac OS. You might be using PuTTY or Git Bash or PowerShell or Command Prompt, whichever shell program that you're using. Go ahead and get that pulled up, and we'll just log into Hyak as we usually do with the SSH protocol and your UW NetID minus Finch KN at clone.hyak.uw.edu. And when you execute that, it's going to ask for your password. But with this cursor key, understand that it's hiding your password. So it might be taking your password, but you can't see it. So you'll just have to rely on your muscle memory here. And that password is the same password across all of your UW applications, your email, and so forth. And then use your Duo two-factor authentication to log in this way. Kristen, could you please enlarge this font? Yes, of course. Okay, so I enlarged that. If you ever are using terminal, you can use the Command plus to get your terminal bigger. Sam, is that looking good? Let me make sure my whole window is in the screen. Right. Okay, so the next thing that you want to do is we're going to pull up a compute node. And the first way to know how to do that if you're a brand new user to Hyak is to use the command hyak alloc. And this will show you your account and the resources that you have available to you. So as part of the UW Hyak team, I'm part of UW IT, that's my account. You'll have something different here. And then I have these partitions that I can send a job to, including GPUs. I used to be a postdoc in the Wasser lab, so I still have this available. It looks like we have lots of nice checkpoint resources available. If you're a demonstration only account user, yours might look something like this. I'm just gonna pull an account from someone I know has an account like this. All right, so if you are a demo account user, then this is what you'll see, and you'll have a slightly different command to use to get a compute node. So let's try, if we can all please pay attention to these partitions that we have. I'd really like to save the checkpoint partition for folks who really need it, so folks that are on a demonstration account for this workshop. So if you have a compute or a CPU G2, even some of these GPUs, if you go ahead and would use that instead of checkpoint for this today, that would be great. So it would look something like salloc, that's to get a compute job, -- account. If you have more than one account, if you only have one account, then it will default to the account that you have. I'm going to put UWIT because that's my main account. I'm going to do -- partition. And then if you have a compute partition or any other of those partitions that you have priority access on, which would be up here, then I want you to put that next. So partition equals compute, could be compute - big mem, any of those. And let's go ahead and ask for a time equals 2 hours. And that will last us for the entirety of this workshop. So that's great. And we don't need a ton of memory. So you could try and get maybe 80 gigs if that's available to you. You might have to play with this a little bit to balance what's available in your partition. So if a lot of your lab mates or someone is using a partition, they're not going to be able to get that amount. You'll have to balance this out. But anyway, that's how you would do it. I'm just gonna copy this for myself later, but what I'm gonna do is I'm gonna show what it would look like for a checkpoint user, checkpoint only user. So you would probably do something like salloc -- partition. It will default to your demo account, so don't worry about account. And then you can go checkpoint like this, so that CKPT stands for checkpoint -- time equals 2 hours. If you're just waiting for me and you already have your command going, just go ahead and execute that command and we'll wait for everyone to have their jobs ready to go. Mem equals 80 gigs, could be 50 gigs. You'll be all right with any of these. So that's what it looks like for a demo account. I'm going to go ahead and put it in here. Please write into the chat. And oh, that was just to Matt. Sorry about that, Matt. Here's to everyone. All right, so that's what it would look like. Like I said, I'm going to go back and use compute so that I can keep the checkpoint resources open for folks that need that today. It's not doing it. Another thing I like to do, I used to use history and then grep salloc because I can never remember what my partition combos are that I used. So I'm just go ahead and copy this one, but I'm going to change it to have 2 hours and 80 gigs. So that's a great way. So if you're new to Linux, then you'll know that the history command is tracking it's tracking all of the commands that you have done here. And so that's the history of what I've done today, getting prepared for this workshop and even yesterday. But if you do history in combination with pipe and grep, and then you just look for something like I could even grep, maybe that won't work, but let's try it. And I can see all the times that I obviously use history grep salloc quite a lot. So yeah, there you go. So that's a good tip. Hey, Kristen, we have bought a slice and I'm trying to get our accounts activated for some time now with no success. Can you help us? Oh, so Jeff, I think that your slice isn't ready yet, unfortunately. It's going to be in our next deployment, which is going to be, I think probably this week. I think they're going to be deploying that today. Or not today, sorry, later this week. They told me yesterday that it's going to be very soon.
Okay, awesome. Thank you.
Yeah, so for now, just go ahead and do the salloc and then to the partition checkpoint. And that'll be good. And yeah, we'll definitely be in touch with you soon. I know that they just needed to switch everything on and then do the final checks to make sure that that was going to be allocated to you guys. All right?
Awesome. Thank you.
Yeah, you bet. Okay, so while that's going, I'm going to go ahead and switch to telling you more about, so I want you to go ahead and execute that. So mine is already done getting on my, getting onto compute node. Is this dead? No, it's good. Okay. So just go ahead and execute that SLOC so that it starts getting your job. We're waiting really on the checkpoint jobs, but I should say that there are resources available to you. So let's talk about what a container is. A container is an isolated software environment that encapsulates an application, along with its dependencies and its runtime settings. And so this can be useful because it provides a consistent and reproducible way to package, distribute, and run software across your computing environments. So if you are working on a Python package or some software or a full Python protocol or a full R protocol, one thing that you can do to ensure that someone is going to be able to do that without having to go through all of the pain of tracking down all of the versions of R or Python and this and that package, you can put it all into a container and they'll be able to run everything following your instructions on whatever system that they're using. So it's another thing that you can publish with your paper. This is a great thing. We're always looking for more things to get our names on, right? And so you can publish that with your code, with your paper, so that you are ensuring that you have reproducible results and that someone else who doesn't want to reproduce your results but wants to do what you did and apply it to their system can do that. And like I said, developers are on board with this because it makes for fewer headaches. Folks don't, get upset or fill out issues on their GitHub if they have containers available to them. They might still get issues, of course, but it's a good method. So this is what a container looks like over here on this side. This is kind of a schematic of what you'd see. So the infrastructure that you have is Hyak clone, so that's the hardware. And then you have the host operating system on top of that. And so we're using Rocky Linux. And the container actually uses the host operating system, but like I said, it runs the host operating system, but it has the applications on top of that. So the host operating system runs Apptainer, which is our container software. And then you have all of your apps kind of plugged into that, and you can switch between apps. And so that's kind of your schematic of what you need to think about. This is the difference between virtual machines, which all virtual machines have their guest operating system. They also have a hypervisor, which can make them really chunky and like slow. Sometimes you see latency with virtual machines, and containers kind of solve that in a creative way. So that is that. Let's see. I started getting into containers because one, it's a policy for Hyak. So when I got here as a postdoc, it was a policy that I needed to install software this way. The biggest one that I had was that there was an R package that was completely deprecated. It wasn't even available on CRAN anymore as a current version. So any R version 4 and up was not going to be available for this R package. And I really needed it because I liked what it did and I couldn't find a replacement. So I built a container that had the old version of R, which was still available on CRAN. And then I installed that package and all of its package dependencies from the old versions of those packages that it needed to run. And now I have this package that's available to me and whoever else needs to use it into perpetuity, which is really nice. So that's one example of why you might need to use a container if your software is an older version or a version that's not compatible with Rocky Linux. One thing that I see some labs do is that people in your lab can all share the same container. So if I go to, you guys won't be able to do this, but just to show you the Wasser lab, we have a directory there that's called containers, where we've saved all of our container images. Now whoever needs them just needs to give the path to this directory and they can use all of the containers that we have either built for ourselves or gotten from the internet. Just gonna go back to my home directory. Another thing that I should say is that you don't have to do everything yourself. So there are a lot of containers that are already pre-built, and this is kind of an awesome thing. I would first go to Docker Hub. So Docker is a different version of a container running software. So like here on this diagram, we have Apptainer. It's because it's really the biggest difference is that it's better suited to HPC environments where you can't be the root user. Docker is a container software where you do get to be the root user, and you can install Docker on your local computer. This is what Matt was talking about in his first question. You can install Docker on your local computer, and you can actually build containers on your local computer in an interactive way or with a Docker file, which is kind of like your recipe script for what went into that container. And then you can push them up to Docker Hub. So here's my profile on Docker Hub, where I have these containers that I've built in the past. And so you can build them here, put them here, and then I'll show you how to pull containers from Docker Hub to your to Gscratch or to Hyak clone. And so this is Docker Hub. Let me see, I see a question. What's the difference between a container and a virtual environment made with Conda or the like? I think that a virtual environment is similar, and it's just kind of putting the packages and their environmental variables into your path. So it's doing something similar, except that containers are isolated, and I think that the virtualization of Python environments is that it's always bound to the host operating system, and we'll talk about that a little bit more. So what I mean is you can activate your Conda environment. That puts all of the environmental variables for running that. So, or all of the modules are kind of available to you. So you can call Tensorflow or you can call, whatever you want, and you'll be able to run that. But if you call Python too. And it's a little bit more direct. So I think it takes out this layer. So it kind of just activates your app on top of the host operating system directly, I think. So good question. All right, so talking more about, you don't have to do all of this yourself. So if you're looking for, since you brought up Conda, there is Conda containers already. So this is another way. If you've been experiencing difficulties with running Conda on Hyak because of conflicts between different versions of Python and this or that thing, then you can actually build a whole container just for Python and the modules that you need to install there. Back on the home page for Docker, they've kind of listed some of the biggest, most popular containers. TensorFlow, we'll use something like this later. PyTorch. It really just takes out a lot of the work that you have to do. So instead of building your, Conda, and then you make your environment, and then you wait and you install PyTorch and all of the different things, and then you find out that you're out of disk space and you have all of these inodes or these files open, you can just download this PyTorch container. Now you have everything that PyTorch needs to run in your container, and it only counts as one file instead of thousands. So that's another benefit of this. Was anyone else able to get? Yeah, so I'm wondering if anyone is still waiting on their checkpoint node. If it says that it's still waiting, that you haven't had an error, then we'll just keep going. But let's see. I think Jeff, I think this is, yeah. So you have one. Oh yeah, it's still waiting. You know what you could do, Jeff? You could SSH into this node if you can. You could do like SSH N3144, and you could
Oh, it's
go
still
in.
connected.
Yeah, that one's still running.
Oh
But
wow, that was unintentional.
it wouldn't it wouldn't that one's been going for like 2 hours. It won't interfere with what you're about to do next, but if you do have some job running, you could go into that one. I think on your demo account, you're only able to submit one job at a time. So that's probably why you have this one running. Another thing you could do is you could do scancel. Oh, but spell it right. And then you could cancel that job by picking up this I see it's a RStudio job. Either way, but you could do it like that and you could cancel it. I can't cancel a job for you. And then that
Okay.
would allow these other ones, this one that you're waiting for, to go through. Because I think with demo
Awesome.
accounts, you can only have one job going at a time, but not for
Cool.
long because your slice is coming. Don't worry.
Thanks.
All right. Okay, so a little bit more about this. So there are other repositories, and we'll talk more about this repository at length. Docker Hub, it's really the best one. It has the most containers. There's also biocontainers, which of course is for biology containers. You go to the registry, you can look up things like SAM tools. For example, it's a bioinformatics software for alignments, and you have some options for SAM tools. Similarly, on Docker Hub, you could look up SAM tools. And also the biocontainers container has been added to Docker Hub. So you could do that. There are some big names in bioinformatics, the state public health bioinformatics community. You want to be careful with some of the containers that you find. You need to test them out on your own, but they can be submitted by anyone. So really you want to look for the ones that are updated most recently. This one's updated 5 hours ago, whereas this one from who knows this person, we don't know, is updated 2 years ago. So it might be an older version, right? Even the biocontainers one is a bit out of date, but SAM tools, I haven't seen it change too greatly, but it could mean that you don't get some of the features that you're looking for if you're looking for a more recent version. So anyway, that's biocontainers, just so you know that it's available. Finally, NVIDIA is the manufacturer, the supplier of our GPUs, and they have this really cool website called the NGC catalog, where you can kind of explore some things. They have Llama containers for your large language learning models. If you click on this containers button here on the side, then you'll be able to search for the containers that they do have. So like I showed you here on the home page, Docker Hub has a PyTorch container from the PyTorch folks. So that's the like Python Foundation or the Linux Foundation, but also NVIDIA has a PyTorch container. Oh, but you got to spell it right. There it is. And so if you click on these, you can kind of see what things they have included. And they're really in it with Docker, so don't worry about this. I'll teach you how to pull these containers. But it talks about the different things that it has available to you inside of that container, including CUDA. These are things that can be complicated to build on your own on Hyak, like a PyTorch container that has everything that you need. If you start with this container as your baseline, and then you install your packages on top of that, you've already got PyTorch taken care of. You just have to worry about those other modules. All right, let's see. I got a question. Can we merge PyTorch container and our own container? No, but I'll show you things that you might do to consider building your own container on top of the PyTorch container to make your custom PyTorch container. It's really magical. All right, anyway, we're going to leave this here. We're going to go back to Python and we're going to get into our, I did want to do one more thing. So I thought this was cool. So when I was getting ready for this, I saw they have this beautiful little clickable LLM everywhere. So it's large language models talking about Hugging Face with Docker. Let's click on that. This is just an article talking about how you would build a LLM or a Hugging Face container in Docker. But one of these great things, which I'm going to ask Kyla to share the link for how to convert your Docker file to Apptainer in the chat. It gives you instructions for how to build this Docker container, but we can use the same instructions to build that in Apptainer. So this is just something I thought was cool. I'm going to click on what she dropped into the chat. So Apptainer has this table where if you're looking at a Docker file, which is a Docker recipe file, versus a Apptainer definition file, that's what they call their recipe files. And we're going to build some of those today from scratch. This is a little conversion table. So in these different places, these are the commands that you would use in your Docker file versus the commands you would use in your Apptainer definition file to build your containers. So I just thought that was cool that, Docker, they find out what's popular, they write a little blog about it. It's kind of like a quick demo, a demo that you can do by yourself, but you can build on top of that and use it in Hyak and have your nice container for what you want to do there. Another thing you can do is you can just, start Googling, I had a user that wanted a FSL. So FSL is how to process MRI images. And I just Googled, oh, maybe someone already has a Docker container, and they did. And I found that there was a Docker file out there, and I converted it to Apptainer, made some updates to it, and I was able to help them build their container for FSL to use on Hyak. Is it possible to run MATLAB within a container? Yes, it is. I think MATLAB also has containers on Docker. Let's check. Bam. Also, we have a module for MATLAB, so you can do it that way. That's another option. But yes, you can make that custom. I don't know very much about MATLAB. I don't know if that's something that you would do, but maybe it is. So there you go. All right, we're going to move on with our demo because it's time to start doing stuff. Just going to close out some of these so I don't get confused. All right. First thing I want to point out, today we're going to the first container that we're going to build is Python. So Python, trusted source. This little thing means it's an official Docker image for Python. We're going to click on that. So when you go into a Docker repository to find an image for a particular software, it gives you a little bit of a rundown. This is all the versions that they have available. They're very up to date. But if you go into the tags, if you, for whatever reason, you want to find a version of Python that is previous, like maybe you want to look at the options for 3.8 instead of 3.9, you can search it here, maybe. Well, you can search it here. If it works, then hopefully it will. But what I should say is that these are all the previous versions of Python that they've made containers for. I do see that there are Python 8s available, so I'm just going to stop searching for that. Oh, here it is now. Okay. Anyway, so you can go all the way back. Let's see. If you go 10 pages back, they have tons of different versions. So probably anything that you can find here. This kind of went forward in time, I guess. But anyway, so we're going to go ahead and go back to overview. And actually, sorry, I'm going to go back to the newest tag. So we're going to pull the newest container version of Python. And the way that you want to do that, so we're all on our compute nodes now. Hopefully that's given it enough time. You can tell that you're in a compute node because instead of Finch KN at the login node, now I'm Finch KN at a host called N3432. And I'm in my home directory. First, I actually wanted to go, let's go all to the gscratch scrubbed, because this is where we have usable space. We're going to be downloading some containers. They can sometimes be big folders. And for this tutorial, I just want you all to, if you don't already have your own directory in Scrubbed, go ahead and make one. I'm going to make a directory called Kristen F. So don't make one because then I won't be able to make it. And that's my name. You can use your own name, your username. You can call it tutorial. You can call it whatever you want. It's just going to be a temporary directory where we can work in for today. I'm going to cd into Kristen F. If I pwd, I see that I'm in gscratch scrubbed in the directory that I just made. I want to copy, just like the last tutorial, I want to copy the files that we're using for today from /software/Hyak, not 2 slashes, /Hyak101/basics. I'm actually going to copy this recursive because I want to get the entire directory and everything that's inside of it. So cp-r/sw/Hyak101/basics, and then dot to say copy that all right here. And if you were at last week's tutorial, you might want to recopy this directory again, because I did make some changes here, and there are some things that we need just for today. So if If I ls, now I see that I have basics. I'm going to go into the basics, and this is going to be my working directory for today. G-scratch, scrubbed, Kristen F, basics. Just a reminder, CD is to change directory, PWD is print working directory, and CP is copy -R recursive. LS is to list. If I list, I see that I have several things in this directory. If I ls-ltr, it will show you the timestamps and the long form version of this directory list. All right, so you have to be on a compute node to use Apptainer. Apptainer used to be loaded as a module, but it's not loaded as a module anymore. So you can take out that step in all of your scripts. You can just do Apptainer -- help, and you're able to see the help for Apptainer. And also you can look at all of the subcommands for Apptainer. So for example, if I do Apptainer inspect -- help, then it will show me all of the specific flags and everything, all the specific documentation just for the inspect command of Apptainer. So Apptainer is ready to go. We're going to pull our first container. It's going to be this version of the Python container from Docker Hub. So Apptainer is able to convert in real time or just by your command, convert a Docker container into an Apptainer container. So we're going to do Apptainer pull Docker : // That's the magic part that says I'm pulling a container from Docker Hub, but I want you to convert it into an Apptainer container. So this is good stuff. And then the next part is you can go into here. So this is the command that you'd have to convert this Docker pull, and then that's what you have to convert into your Apptainer pull Docker : //. So we're just going to copy this part. And we're going to grab this Python : 3.9.19 - bullseye container. So we just copy that last part. So we're saying in the Python repository, pull this specific tag right there, and it's going to start doing that. All right, it's just going to take a little bit, 2 minutes. So if you guys have any questions, go ahead and chat them or unmute yourself. Hopefully we're all on the same page.
Hey, Kristen, I have a question.
Yep.
So that looks like is it safe to assume that bullseye is actually from Debian? So this is maybe a container that was originally developed under Debian bullseye, and now we're going to be pulling it in and running it on a Red Hat Linux node. Is that right?
That's correct.
Oh,
yep.
That's kind of cool.
Yep. And I think that they probably have, well, maybe they have more information about their things, but I'll show you the command to find out what a contain, like more information. That's the Apptainer inspect, not suspect, Apptainer inspect. Okay, let's see. Can you say more about the OS Arch options we see on Docker Hub? Yes. Okay, anything we need to be careful about when pulling containers? Yes, that's correct. So, and we'll see this with a container on NVIDIA. I shouldn't have closed out NVIDIA. Let me go ahead and open this back up. So if I just search the NVIDIA, yeah, it's already here. So I'm just back at that same place that I was before. If I click on containers and I go TensorFlow, and I click on the TensorFlow container, same thing. It looks very similar to Docker Hub. If you go to tags, that's kind of the versions. So here's one thing that you need to look. So architecture or Arch, what is being talked about in the chat, is something to pay attention to. And so this version right here, it only has the architecture for ARM64. And unfortunately, this is incompatible with our AMD 64 architecture that is running on clone. And this really has to do with the processors. So there is something to be careful of. So when you're building your containers on, if you're building them on Docker locally, and you, like me, are on a newer MacBook that has ARM64, and you don't do anything to change the architecture or to make a container that can be used on multiple platforms, then it will not be compatible with use on clone. And so that's outside of the scope of this talk to discuss how to make those cross-platform containers. But after this workshop, when I send all of the resources in a email, I'll include a documentation site that I found that walks through how to do that. So what you want to look for is like this version of the container, which has two architectures. AMD 64, but it also has ARM 64. So AMD 64 is the one that we're running. ARM is the one that might be some of your MacBooks, and I think there's another provider of that as well. So Apple kind of started to adopt those. Okay, so that's what you have to be careful for. And you will just have, if you try to pull this container, it will give you a result that just says that it gives you a fatal error that you can't do that. And so that's something to look at. If you think you got everything else right about your command, then going back here and seeing if you got the right architecture is something to look at. Let's see, on the Docker side, I think Docker, it makes like really, they really do a good job. So these big providers like Python, they do a good job of making cross-platform compatible containers. Okay, so Matthew, Apptainer inspect. Oh, I should say our container is done. And here is our new container image. So all container images have this ending called .sif, and that actually stands for Singularity Image File. And so Singularity is the old name of Apptainer. Apptainer is now been adopted by the Linux Foundation, and it rebranded, and so it's more open source. I think, at least it's free, I'm pretty sure. Anyway, so they rebranded, but it's still carrying the Singularity brand in the ending. So this is our new container image file. So if I want to inspect this, I can use Apptainer inspect. And then I can start just typing Python, because that's only Python in here right now, and just tab to complete. And so let's see, it says AMD. It doesn't say that it's Debian, but I'll show you how to find out. Okay, so that'll be coming. But what I wanted to show you is that we do have a native version of Python installed on Hyak. So if you did Python -- version, we see we have 3.9.5. And so if we wanted to go in now and use the Python, if we're not happy with 3.9.5, we wanted to use the one that we just pulled, which is 3.9.19-bullseye, then we can do Apptainer shell, which will open up a shell inside of the container where we can run Python this way, and then pass it our Python container image like this. And you'll know that you're inside a container because your command prompt has changed to say Apptainer. Some older containers that were built with Singularity will still say Singularity here, but this one says Apptainer. We just grabbed it, right? So if I do Python now, and I open up Python, we see that we have our Python kind of welcome message, and we have GCC installed with this container, 3.9.19. And then if I exit, actually, if I just Control D, that's how I exit Python, Control+D. If we do this command cat/etc/issue, this is where it's telling me Debian or Debian.
Oh, thanks for showing that. That's useful.
Yeah, so some of these inspect, so some of this metadata will give you more information, and we'll see one that does that. But this is what is available for. So I think it's just up to the container folks who are building the container to put as much or as little information into that metadata as possible, or as they like. All right. So any questions? Because we just shelled into our container. Now we're inside of a container. We can ls and we can't see any of the files that we had access to outside. And that's another thing that we're going to talk about. You actually have to bind the file system to your container to be able to use it. And before I demonstrate that, I want to demonstrate one more command with Apptainer, which we'll use. So if you want to exit the Apptainer shell, you just exit. And now I want to do Apptainer exec for execute, and then pass it again my Python 3.9.19 bullseye image. And then I'm just going to do Python this way -- version. Oh, and I have to spell Python right because it won't work if you don't do it. And that's another way that you can pass the image and the command directly if you use Apptainer exec. I could also just start Python and not ask for the image just by doing it this way. So if I did Apptainer exec and then pass my image and then say Python, it goes right into opening up the shell. So I'm now back inside of the shell, but I'm also inside of Python, the Python shell in there, or the Python console. And now if I Control D, it goes back all the way to our host environment, bypassing the shell part. So that's another way. I hope that's clear. So if we use Apptainer shell, I'll just scroll up in my history. Then I get my Apptainer prompt. I'm inside of the container and do Python. Now I'm inside Python, Control D to exit Python, still in the shell of this container, exit the container, and now I'm back. But if you do Apptainer exec, Python container image, and then Python, it just goes directly into Python. And then if I Control D, I'm back out. So it's really the same, doing the same thing, just with different steps. And there might be different reasons why to do that. Oh, do you have a different version? Oh, it might be that your base environment. Do you see how in front of your so Matthew in the chat, he said that he's got a different version of Python when he does just Python version in the host environment. But I can see on your prompt that out to the side here, you have a Conda base environment activated, which is probably loaded with your bash.art or your .bash rc, so your bash profile, and that has followed you over to your node. There are ways to do that.
Good catch, Kristen. So I have Python virtualization and Apptainer virtualization going on here.
Correct. Yeah. When you do Apptainer? Yeah, you still see the Apptainer version that you pulled from Docker when you're inside of the container. So yes.
Sorry, I hope I'm not confusing anybody else.
Oh no, it's okay. That might have happened to others as well, because so when I'm on the login node, I do also have or actually I don't. I've disabled that I have my base Conda environment always activated when I start a new job, but some people might have it on auto activated. So if you saw a difference in the home or the Python version that's native on clone, it might be because you're running it through your Conda. All right, so I want to just demonstrate even further by making a little, this would be how you pass a Python script. So let's nano and let's do a script called pi, like the number, .pi for Python script. This script is going to be so, trivial. It's just going to import math. And then we're going to, we're going to print statement. Executing inside the container, exclamation point, close quotes, close parentheses, and then print pi equals, comma, math dot pi. All right, so what I've done now is I've opened a text file and I'm making a little short Python script just for fun. And I'm going to have it load the module math. and then it's going to print a statement, and then it's going to print a statement and also print the pi number. So if I want to exit Nano, I do Control X, and it asks me if I want to save this by using yes or no, and I use Y to say yes, and I want to save it as pi.py. All right, so if I wanted to pass this script to the container that's running Python, here's what it would look like. Apptainer, exec, and then I grab my Python image, and then Python pi.py. So this is how you execute Python script, is by just starting Python and then passing it the script. But oh, it can't find it. It cannot find the pi.py because there is no such file of that inside of the container. Remember, I said that it won't have access to your data or to what is on the file system unless you give it specifically. So we're going to do Apptainer exec, and how to bind the file system. This is going to be necessary in almost all cases of using your containers if you want to apply commands to the files that you have or execute commands on the files in the file system, is to --bind /gscratch. And that's all that you need to give, just --bind gscratch. That's the name of our file system. Usually anything that you'll need is going to be in that file system. And so that's all that you need to do to bind the file system to your container. And now if I do the same thing, Python image, and then Python, and then pi.py, enter. Executing this inside the container, pi equals 3.14, blah, 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 right? All right, does that make sense? Let me see, let me test one thing. So I'm gonna also show you when I bind with the shell, right? Apptainer, shell, --bind, gscratch, Python, and then just to open the shell. Now I'm inside of the container again, but I've bound my file system. So if I ls, now I see my files there. And I can do Python pi.py from inside. Bam. Beautiful. These are all tricks, stumbling blocks. Yep. What's up?
So this might be kind of dumb, but so is the same file system, like whether you're in a login node, a compute node, or within the container, it's always the same file system. It's just that you have to sort of give it the right parameters, for example, binding it to a container.
Yes, that's correct. So the login node, the file system will, when you can use /gscratch and then your lab name, for example, or any of your home directory or scrubbed, for example. So all of that is continuous. If you're in the login node, you're in a compute node, you're in a GPU node, all of that is the same file system if you're on clone. And then the only thing you need to do to make that available to your containers is to use that bind, that --bind gscratch.
Awesome, thanks. I was worried that I was going to have to like redo file systems for every different one of those. So that's great.
Oh no, it'll just be that. So this part, this --bind gscratch, will be consistent across all the times that you're using Apptainer on clone. So, all right. Now we're going to. You get a fatal error. Let's see.
I have a problem. I'm sorry, is this an okay time to
Go ahead, yeah.
So it looks like I don't know. I'm not sure what pi.py, which directory I'm supposed to be in. Maybe I'm in the wrong place.
Oh, okay. Let's see. If you pwd, what do you see? Oh, did you make? Yeah, did you? So a second ago, we actually made the pi.py file for ourselves. So we used Nano to do pi.py.
Oh, I missed that step. Sorry. Okay.
Oh,
Well,
that's okay. So it would just be, I'll copy this and put it into the chat so you can catch up quick.
thank you.
And then, so you'd go into Nano, paste that in there, Control X to save it, and then now you have your own version of pi.py. That was not something that was something I was doing on the fly. I didn't include it in the basics directory.
Okay. Thank you.
Let's see, Sarah. So is there a reason why Apptainer execute this Python pi.py is unable to find? Yeah, Sarah, it might be the same thing. I feel like your Apptainer execute -- bind g scratch and then your image pi. Oh, you have to put Python. I see. You're missing Python in your command, Sarah. Let me go up in my history to find that. Right here. So you're missing Python right there. That's why. Okay, and then it seems like the default Apptainer binds the home directory because I can see ls without binding anything. Does Apptainer shell use some default bash rc as well? I found it useful to do source bash rc, so I have my usual preferences. It's possible. Let me see. When I do, I mean, it could be that there is a default like home. Yeah, actually, you're right. So I'm going to shell back into this without binding this time. So there is some of the file system. So the thing is that, well, it's kind of advanced, but the gscratch file system is actually a separate device from where the home directories are. So if you ls and then your tilde, it is going to show you what's in your home directory. Because if I go to cd the root of my container, I can actually see that gscratch file system is there, but it's unbound. And then mmfs1 is where my home directory lives and stuff. So it's a little complicated. I don't want to confuse things by saying in all cases, and I don't have a way to test that right now, but it is possible that you have some of your user environment. You can execute Apptainer on a clean environment if you do this. If you ever like have a environment variable that is in conflict with what you're trying to do in the container, you can turn off all of your environment variables, and then like your home directory is included in one of those. So you're like this variable home is your home directory. Yep. Okay. All right. We're going to build a container next. So keep the questions coming, but put them in the chat and I'll get to them a little bit later. All right, what we're going to do now, we're going to find a different container on Docker Hub called Ubuntu. I know you're familiar with this. This is another Linux-based operating system. So it's really just going to be a stripped down version of the container that we were just using, and it's not going to have Python inside of it. But anyway, we're going to go ahead and we're going to pull this container. We're going to pull the latest. So this is something I wanted to show you as well. So if you Apptainer pull docker //Ubuntu, and you just leave it at Ubuntu, you don't go into the tags and find a particular tag, it's going to pull the latest tag. So the one that they have decided is their like latest and greatest version. This is the latest. It was actually updated 5 days ago, so it's pretty good. So it's running all the architectures here that are available, and you just execute that. It starts pulling your Ubuntu container, and now instead of having the whole name like we had Python 3.9.19 - bullseye, it's just going to say Ubuntu _latest.sif is what this is going to be called. All right, that was super fast. Hopefully it was fast for everyone else. So now if I ls-ltr, I see I have Ubuntu _latest. And this one, if we do Apptainer inspect, because latest isn't really telling me what this is, then you can see inside that we're running this version of Ubuntu. All right. So Ubuntu 24.04. Excellent. And then it even shows you the date that it was uploaded here. Good stuff. All right, now I'm going to show you how, if you wanted to, install things in an interactive way on your Ubuntu container. So if you wanted to, I'm going to demonstrate this by showing you how to do Git, how to install Git. But the first thing we need to do is to convert this to be a sandbox. So if we Apptainer build -- sandbox, which is a like buildable version, I guess you could say, Ubuntu _latest. So this is going to actually become a directory called _latest, or sorry, Ubuntu _latest. And then you would pass it our Ubuntu image next. So this is what your command looks like. And it might take, let's see. So that one took, what did it say? Oh, it's already done. So when I was practicing this, it took 6 minutes to do that. So I'm hoping that it doesn't take 6 minutes for you all, and maybe it was just a slowdown that I was experiencing. So I'm just going to cautiously kind of talk about a few more things to go slow, but hopefully we'll all still be on the same page. So now if I ls-ltr, the directory that I'm in, I see I have this directory now. I can tell it's a directory because it's blue, and over here it has a D. So Ubuntu _latest. So if I cd and change directory into that, ls, I see now what's looking like an operating system, because it is an operating system, but now it's inside of a directory, which all operating systems are inside of directories. Anyway, I'm rambling, but you have your binary folder, you have etc., you have your opt, everything, you have your libraries, everything that's just looking how a stripped down bare Ubuntu operating system would look. But let's go back up one more because I don't want to mess things up in there. Okay, is the Ubuntu latest after -- sandbox just the name of the directory the build files will be written into? Yes, correct. So you could name it whatever you want, right? You could go up to this command, and instead of this Ubuntu latest, you could call it like Ubuntu dev for development. You could call it my Ubuntu, whatever you want. But yes, I just called it that to keep things straight in my mind. It might be different preferences for you. Okay, so to install things, is there a means to parallelize, e.g. specify CPU threads when building a container? Not sure. I'll have to look into that a little bit more. I'm not sure if it is parallelizable, but I'd have to do some tests to give you an answer. So let me get back to you about that. Okay. I'm gonna do a shell into this, but instead of doing a standard shell, I'm gonna shell into a writable version of that directory that we just made, which is our sandbox, as fake root. So, which means I'm a fake root user. Apptainer shell -- writable -- fake root, and then Ubuntu _latest, and our directory, not the image. So you get a bunch of warnings because whenever we do stuff like this, it's always trying to find slurm. These are just things that our operating system does. But anyway, it's saying that we're using our fake root, and so now you're in here. And again, we're inside of a container, so we see our command prompt has changed to Apptainer. And now you always want to update your packages in Ubuntu before you install new stuff. So apt-y update my packages. It says that I have 5 packages that are updatable, and it's given me the command. Let's just go with it. And it's done that, so now it's updated these 5 packages. And now my command to install git apt with 1 p -y install curl git. That's the command we're going to use today to install git. So it's going to go ahead and do that. So I should say, this is possible. I have run into problems that sometimes when you're trying to do a sandbox of a Linux container, there can be some conflicts, and it might not allow you to work in your Linux container because I think it's still interacting in a weird way with the host container. So I'm afraid that we won't always be able to give you the best support when you're doing the Apptainer containers in this way. But the next way that I'm going to show you to build containers, we have great support for. And it's actually more recommended. So I'm going to go ahead and try to So listing upgrades it to, it seems like it would just list them all. I'm not sure what that means. Apt list doesn't update the packages. Okay, sorry. Could app upgrade. Okay, not update. Okay. I'll change this in my notes for next time. Could those most recent commands be pasted into the chat? Yes. So we did this one. So the apt update just lists the updatable or upgradable packages. And then it's really just optional anyway. So, but the next one to install Git is here. Oh, and you probably also need the how to build the sandbox, which is this one. And then how to get into a shell inside of the sandbox to work interactively is that one. Okay. So now if we do, yeah, Matt, shout it out.
So I want to understand what's going on here with this build. So you have an Apptainer and you do the build and you give it this sandbox, which creates this directory, this Ubuntu latest directory. Is that the directory of all the files that are inside the Apptainer?
Yep, that's a directory that contains everything that was installed inside of the container image. Yep.
And is that so we can start modifying those files?
Yeah, if you want
That's what we do when we do the fake root shell. That I'm just curious, what is the difference if we didn't say the fake root? If we just said Apptainer shell, we couldn't modify the inside of the container.
Yeah, I think that the fake root part is required to be able to modify things.
Okay, so when you did the apt update just now, you're actually updating the files that are in the Ubuntu latest directory. You're not actually updating the files that are inside the container. Is that right?
That's correct. So the Ubuntu _latest.sif, that's kind of your original version, and I'm not touching that right now. So it kind of made a copy of that version, but then transformed it into this sandbox.
Okay, so basically we are taking this base image. We think of Ubuntu latest.sif as the base image, and we're creating this sandbox version that we can start modifying it, but we really are not. Those are sort of like, we think of those as overrides to the default thing we checked out of the Docker Hub, right? So we're overriding all of those files. It's almost like a search path, so it'll find the things in Ubuntu latest before it finds them in the parent container. Does that sound like a right characterization?
Correct. I think so what we're gonna do next is we're actually gonna take this sandbox, so you can like work in the sandbox just like you're working in the shell. So I think without the fake root, you can still like send commands to this directory if you wanted to. I haven't tried it that myself, but I'm just trying to show how to build. But the next thing we're gonna do is we're gonna take this modified directory and we're going to build that into a new version of the Ubuntu _latest.sif, but now it's going to be Ubuntu _latest-git because we installed Git. All right.
Oh, okay, great. Okay, sorry. That's great. Continue, please. Thank you.
Yeah, no worries, no worries. Okay, so now that we have Git installed, we can do git -- version. And we see that we have our version of Git here. All right, I want to exit outside, so I'm not in the shell where I was writing and installing those things anymore. They're still there. And if I do Apptainer build, and now I'm going to call this Ubuntu _latest_git.sif. Is that how I'm doing it? Yep, so you put your what you want this new container to be called next. And then what you're building from is the Ubuntu _latest. You know what I should have done is I should have called this like Ubuntu _sandbox. So that was better with the names. But anyway, go ahead and execute that. And what it's doing is it's just making your new image which now is not just Ubuntu_latest.sif, but it's Ubuntu_latest plus Git inside of it. And I'll show you the difference once that's done. Said it was gonna, this morning only took 25 seconds, so we'll see. All right. Okay, so I'm gonna go ahead and show you the differences here. So if I'm gonna clear. And then ls-ltr. So you see, I still have my original image untouched, and I still have my sandbox directory, which has been modified now. And then I have my new image, which was built off of my sandbox. So if I do Apptainer exec, and then I do, well, first of all, I want to say just our native Git version is 2.43.5. If we do Apptainer exec, the original one, Ubuntu_latest.sif, git -- version. Oh, hold on one second. What did I do differently here?
Was Git even
Oh,
installed in the original?
Right. I was just trying to make the point that Git wasn't even installed in that one. Okay, sorry, I'm tired. Okay. So that's what that's supposed to say, that Git is not available in this container. Sorry. Ubuntu_latest_git.sif, git -- version. Here we go. And that's the version that we just installed into the sandbox, which we then made into a new version of the Ubuntu container.
And at this point, we can completely throw away Ubuntu latest.sif if we want and save the disk space, because we now have a new customized updated version of that container that
That's
has
right.
everything that was in the old one, plus all the updates we did, right?
Yep. So the new one is a little bit bigger, right? And you might want to keep it for whatever reason. Actually, so you might want to keep it, but you don't have to. So yeah, you can save the disk space. Okay. So that was just showing you how to build a container in an interactive way on Hyak. And so do with it what you want. I don't usually build containers this way because I like to have receipts for everything that I do. So if you on the side, you've got your notes up and you're writing, okay, I did apt get, and then I upgraded these things, and then this was what was upgraded, and then I did install git. If you have your records on the side, then that's great. But you can also build a container with a recipe file, which is kind of Apptainer's version of a Docker file. It's called a definition file. So I want us to start a new text file with nano, and it's going to be called git. I should come up with something different to call it. Let's just call it, I'm just going to call it container build.def, so that I don't confuse you with having too much name overlap. But we're essentially going to do the same thing, where we start with a Ubuntu container and we install git. Okay, but just for this part, I'm going to call it container-build.def, and that stands for definition file. All right, so when I'm inside of my nano file, the first thing that you want to start with is called bootstrap, and this is gonna tell you where you're starting your baseline image. So you're really not building it from scratch. You're going to build it based on one of these plain old operating system containers, for example, like we're going to do here. So we're going to bootstrap from Docker. That's telling it this is our source. This is the repository where we're getting our baseline image. And then from : is how you tell it which image you want to use. And we're just going to use the Ubuntu latest. So all we have to put here is Ubuntu. And then we do %post, and you can write a little note to yourself that this is where I install my software. And what you want to do here is take your commands to do that. So we'll just forget about the apt update part. We'll just do apt-y. curl git as the next one. Can you copy the command to build? Yep, absolutely. Let me grab that really quick. Like that. All right, so this is what you have for your Apptainer recipe file. Correct. Good call. Saving me an error message to deal with. Okay, another thing that you can do is you can give this a run script. So if you want your Apptainer, when you're using another command, which I haven't gone over yet, but if you want it to always have a run script so you can test out your container's validity or test it out that it's doing, it could be like a test or something like that. Let's just say that our test for understanding of this container works is going to be git version, just to give us the version of GitHub or Git that we're using, not GitHub. Okay. So that's our container recipe file. So I think that this is the better way because you have already the recipe, you've tracked everything that you've done, and you can make sure that everything is gonna go from top to bottom and make your new container. So I'm gonna save that with yes. And now I have my definition file here. Yeah, you could, it's gotta be run script, not just run. Did I do run script? Yeah, run script on here. Let's go ahead and add that. Curl -- version as well. I thought, well, I'm wondering, do we have, because it's using curl to install it and it did it without, anyway, let's try it. So Apptainer build. So now you can provide it what you want this to be called. And I'm going to call this git container, even though that we know that it has Ubuntu in here. So that's where you put your new name for the container, and then you pass your definition file to it after that. So it's going to be Apptainer build, and then what you want your container image to be called, and then your container build file after that. And if it gives us an error, we're going to know it's because curl wasn't installed. But let's just try it out. Oh, cannot locate package curl. Okay. It's funny because it worked earlier when I did this. Maybe we do need the apt update. And then apt. Let's try this. I'm going to paste it into the chat. And then I use the up arrow to get back in my history and get at that command again. And it should go pretty fast. There's one thing that's nice about Apptainer is that it has a cache. So it saved our previous, when we pulled Ubuntu earlier, it saved that. And so it doesn't have to do as much work. But that will empty itself. And you can empty the cache yourself if you don't need that anymore. It's going to say something else. Oh, another thing, if you're building a very big container with lots and lots of packages, you can also kind of do this in chunks. So you can start your Apptainer definition file, and you can give it the first chunk of, maybe it's just the basic libraries that you need. And then you can build that, and you can build that into a container. Well, you can also start, like, build a container off of an existing container that you already have in your directory. And I'll show you how to do that next. But you can start to kind of like just install things in chunks and make your container like bigger and bigger as you go, but then have your master definition file where it has all the steps that you've taken to build that container. So our container for Git is here, and now we're going to use Apptainer run so that it prints our run script.
Can I see the build command that you ran before this?
Yeah.
Sorry,
Here it is. All right. So if we do Apptainer run and then just pass it the container image, it's just going to give us the result of our run script. Yes, I can. Oh, it says something is wrong. Well, it says our Git version. So it didn't like doing the curl version. I'm kind of improving a little bit. When I practiced this, I only did the Git version. But anyway, so it gives us our Git version, but it didn't do our curl version. Or it did do our curl version. Here it is. It just gives us a lot of this extra information that I wasn't anticipating needing. So it's just giving a release date and other protocols that you can use with curl. So that's good. It's just what curl gives you when you ask for the curl version. Okay, so back to the definition file quickly. So the parts of this are that you have your bootstrap, that's kind of your source. So the repository or wherever you're getting that from, and we're getting it from Docker Hub, so that's there. And then the specific repository in Docker Hub is the Ubuntu repository. So Ubuntu is like the user that has uploaded this latest version. So it's pulling down, same thing, the latest version, but now it's executing all of these commands onto it so that instead of going from, okay, I've got my version, I turn it into a sandbox, and then I install these things manually, and then I build it again as my new version of the container. Instead, it's doing that all in one go with this recipe file. So you've got those two things, and then your post section, this is where you do all of your install commands. And the run script is really just an option. It can be something that you use to test your container, but I just wanted to demonstrate that that's what you use the Apptainer run command for. All right, I'm gonna keep going. Yeah, I think I'm gonna move on from there because I want to show you how to build from a local image. Okay. So you remember that we pulled this version of Python. And that is awesome, but it doesn't have any other modules installed onto it. So now we want to take our version of Python and let's go ahead and install Tensorflow just for demonstration purposes. So we're going to make our new definition file, right? And this one is going to be called we're going to nano again. So we're making our new file. It's going to be TF for Tensorflow dash Python 3 dot DEF, because that's what we're building. We're building a new container, which is going to have Python 3 with TensorFlow in it. And so we start the same way, bootstrap, spelled correctly, or else it doesn't work. But this time we're going to go from a local image. From is where we put the path to the local image, which I should have copied, but I've got it here in my notes. Where is it in my notes? All the way at the top. Just trying not to have to exit nano here. Okay. Python underscore 3.19.9. Nope. It's 3.9.19 dash bullseye dot SIF. Remember, that's the one that we pulled earlier from the internet. So instead of pulling from the internet and then installing what we want it to do, we can use a local image as our baseline and start to install things here. So we give it our new post section where we install stuff. I'll just say in this section. All right, and then what we're going to do, use pip install TensorFlow. Keeping it simple. We'll make a run script. Like I said, it's not necessary, but just for fun. We're going to have it print us a message from Python. Python-c print. Oh, wait, no, we need single quotes. Print. Hello. From your custom Apptainer image. I'm gonna copy it into the chat. Okay, so all of this is doing is it's just gonna activate Python like we've been doing this whole time, and this is how you can pass a print statement to Python just by calling Python with -c and then passing it the command, which is gonna be your print statement that you want. But the real action is happening up here where we're installing TensorFlow. Control X, yes, enter. So now we have our definition file, ls-ltr. There it is. We're going to do the same thing that we did before to build. Apptainer. Build. Now we're going to give it our new container name next. I'm going to call it, I don't want to confuse things too much. But anyway, you can call it what you want. I'm going to call it TensorFlow Pi3, TensorFlow _pi3.sif. And that's built from our definition file, which is called tf-python3. So I usually just name the container files what I'm going to name the container, but just for demonstration purposes, I'm trying to keep these names distinct so that we are not, because you all are not in my mind, right? And there might be different methods than what you do. So I'm just going to do it this way for now. So it's Apptainer build, your new TensorFlow with Python 3 image that we're building on top of the Python 3.9.19 bullseye container, but we're installing TensorFlow with our TensorFlow definition file. Okay. So last time I did that, it took about 5 minutes. So I have another one here. This is all going to be optional just to kill time. You see that on my screen, it is installing TensorFlow and doing beautiful things in there. It will also give you errors. So as you're going through this process, it says, oh, module whatever is not available for TensorFlow, which in this case, I made sure that that wasn't going to happen, but it could happen for you. And then you have to also install with pip some package before you install this one. It could happen, but what the point is that it's going to give you error messages if you have any error messages in your build, if you're missing a dependency that you need to put in there. And if it doesn't get that from the internet automatically. So that's still going to take a little bit. So I'm going to just go ahead and open up a new one, which is totally legal. Always have like a ton of these opened up so I can be waiting for things to run. And also continuing to do my work on the other terminal. Make this one big too. So that's my login again for Hyak. And the reason is that we really don't have to make this TensorFlow container, because there is a really great TensorFlow container already available from NVIDIA, like we were talking about. I pulled this container and it took about 25 minutes to build. So that gives you an idea of how cumbersome some of these containers can be. But like I said, they've put in a lot of work to install everything that you need in TensorFlow to be running on NVIDIA GPUs. Okay. So for this one, I have already installed, so I'm going to get back to where I was in my working directory in gscratch scrubbed Kristen F basics. So I'm already in the same spot. I want to make sure that all of this is showing. Yeah. And clear. So I have installed and made this container available to you elsewhere. And actually, if we use ls and we start with /sw, which we call, this is where we kind of keep some of our softwares. This is where our modules are installed, for example. We have containers in there that we're going to be adding to more in the future, but we have some specific containers in there that we use for tutorials, also for other things that we have walkthroughs for on the documentation, like the code server container, if anyone has been using VS Code with the code server. So there's a directory in there called NVIDIA and a directory inside of that one called TensorFlow. So if we list this directory, we'll see that this is the container that I pulled for today, which is this one, which has 2 architectures. So it's got the ARM one. We can do, oh, actually, if you are trying to follow along, let's just see. If you have this a job running, so this is how you monitor your job queue with sq-u and then your username. If you have a job running, you can just SSH right back into that one if you have set up your intercluster SSH keys. If you haven't set that up, you can just follow along and wait for your TensorFlow container to complete. Oh, it's gonna be one of those days where this doesn't work. Nope, there it goes. Okay, it was just being slow. There we go. Okay, so I'm back in here. And it put me back on my home directory, so I'm just gonna go here. So if I Apptainer inspect and I grab this entire path because I'm not inside of that directory, and I inspect this container. So NVIDIA, like I said, they do a lot of work. They have showed us many of the libraries that they have, the versions of those libraries. Here's TensorFlow version and other TensorFlow libraries that go along with TensorFlow. And what it's running, it's actually a Ubuntu container, again, 22.04. Okay. So with that container, I have put inside of your basics container a little script, which we can look at. You guys don't have to make this script. It's just the basics tutorial from TensorFlow inside of a little script. And I just wanted to show you that this container runs TensorFlow just as you would expect. And so if we Apptainer, and my other one just finished, so that's good. Apptainer exec, and then we do that full path to the container. So you really, if you ever want to use this container, it's going to be there, so you don't have to rebuild it yourself, which is really nice. You're not using up disk storage for your lab. NVIDIA, TensorFlow. Okay, and then we do Python again because it's a Python script that we're passing, and it's called tf_tutorial.py. And that'll go ahead and start running. And now if I switch over to the other side, now my TensorFlow custom Python is available in my working directory. And I can do the same thing, Apptainer exec. Now I can give it my TensorFlow container that I just built, and I can say Python and then tf_tutorial like this. And we can just look at them. Oh, you see what I did? I didn't bind to the file system. I always leave these errors in my notes because I'm like, oh, just point out that it's an error, but then I get surprised by it. That's going to be my disclaimer. This was a planned error. Okay, so you need to do Apptainer execute bind gscratch because that's where this tutorial.py is, tf_tutorial.py, and it won't be able to find it because it doesn't exist inside of this container. So that one's going, same thing over here. Cursor back in front of exec, or behind exec -- bind, gscratch, enter. And we'll see that that one is going over there. And this one is starting over here. So the epics are already training on this one. All right. So I meant to end at 3:30 and it's 3:38. And I promised that these would end on time and I'm a little bit late. Sorry about that. But this is all good stuff. That's all the material that I had planned for today. If we had extra time, I was gonna do something else. And if we don't have any questions right now, I'm gonna be sticking around for until 4 p.m. to answer all of your questions for the next half hour. But yeah, that's about it. So we can see that in our custom container where we installed TensorFlow, it had a little bit different way of coding how to show the epochs. And then it gave us our congratulations message, which I put into the TensorFlow tutorial Python script that we ran. So it says at the end on both sides, congratulations, you've trained a machine learning model with a pre-built data set. Yep, you bet. Thanks for coming. Class dismissed unless you have questions, or unless you want to stick around. If we don't have questions, I'm gonna show you something else. You're welcome, Jeff. Thank you. Thank you all for coming. I'll email you with the recording.